Here is my spreadsheet program. I click in this cell and press equals. I can now choose from a bunch of functions. I choose the sum function and select the numbers. And that works. Now I copy the columns to another column. I click in this cell and this time I choose the average function. And that works as well. But how does it work? Here is class cell. It has a method to set the operation name and the range of source cells. The information is stored in the object. The getValue method does two things. It gets a list of numbers from the range of source cells. Then it switches on the operation name to perform the chosen operation. And of course, this would work. But you already see a big problem with this. The list of operations is huge. Each operation needs to have its own place in the switch. And future operations in the spreadsheet program require the switch to be changed. A problem like this is known as an open-closed principle violation. The system cannot be extended without changing code in other places. And there is another design principle violated. The single responsibility principle, which says modules should be responsible for only one thing. But this function is responsible for getting values from a range and choosing and performing the operation. This function would need to be changed whenever the list of operations changes, or operations themselves, or something in the cell range logic. Changing one thing might break the other thing. It is time to do things differently. And for this I will use a design principle. Separate code that varies from the stuff that stays the same. I moved the operation code to separate functions. Each operation gets its own function. And now when I choose a cell operation, I do not pass the operation name but a reference to the operation function. When getValue is called, all it needs to do is call operation function with the list of numbers. That certainly cleans up the code in the getValue function. All the operations have been moved to functions. In the strategy pattern, they are known as strategies. Then there is the strategy interface. In this example, the interface is a callable, better known as a function. In Python, that is an object with a single method that will be executed when the object is called. The cell class, which contains a reference to one of the strategies, is called the context. Together they form the elements of the strategy pattern. And once you recognize it, you will see it everywhere. For example, the strategy pattern is also built directly into Python. Here is an example. Look at this list of names. I print each item and here is the result. I add a function that returns true if the salary is less than 2000. This is the strategy. Then I use the built-in filter function and pass the strategy function as first argument. I run the code and this is the result. You know what it is?
Yes, this is the strategy pattern at work.
Until now, all strategies were functions that only did a single thing: return stuff. But strategies can be anything. Here is a list of audio devices on my computer. All three devices are capable of sound input and sound output. Each must at least have these two methods. When I choose a device, the audio manager, which is the context in the strategy pattern, will store a reference to the chosen device. And the play and record methods delegate the work to the chosen strategy. All this without having to switch on devices. You know what it is?
Yes, this is still the strategy pattern at work.
And it's a good thing that we don't need this hard-coded switch with all devices. Because when you think of it, how could it switch on all devices? Operating systems are not shipped with drivers for all audio devices in the world. These audio devices need to register themselves as plugins. Now, the basis of the strategy pattern is, of course, polymorphism. It allows you to abstract and encapsulate behavior behind interfaces. This allows to extend the system with new functionality without having to change existing code. You can even use it to extend the system with third-party plugins. And to see how that works, click on this video. There you will see how to create and load plugins in Python dynamically.